So let's suppose that I have this function and the second derivative is continuous. And f of 0 is 0, and f prime of 0 is, let's say, 5. Calculate the following limit. Limit as x goes to 0, f of 3x squared over x times e to the x minus 1. Should be quick. Yeah, we can even spice it up a little bit. We can do e to the negative 2x minus 1. How about that? Alrighty. So why don't you try this? I'll give you a few minutes to try it. All right. Remember, I mean, don't be intimidated that there's the symbolic function f. You don't have to really know what f is. You just need to know the given information. All right. Think about how we calculate limits. Right. And think about what tools we have to calculate limits. So let's do, say, 3 minutes and some change, and let's see how far you can get here. Okay, if you're initially stuck, what do? You do direct substitution first, and that gives you a hint of how to proceed. All right, so let's see. So how far did we get? So let's copy this. So who wants to volunteer? So what was your first step here? How did you first approach this limit? So I should give the hint of direct substitution. No one. L'Hopital's rule, Maya? So what do you get when you actually directly substitute x equals 0, Maya? Because we have to make sure L'Hopital's rule is actually applicable. Right, you do get 0 over 0, exactly. So direct substitution gives 0 over 0. So L'Hopital's rule. Okay, so let's use L'Hopital's rule. All right, so up top, we get what? This is just, up top, we just use chain rule. That's it, right? We get f prime of 3x squared times 6x by chain rule. Right, so it's just one straightforward application of chain rule. And the bottom, we have to use product rule, right? So 1 times e to the negative 2x minus 1 plus x, I don't have enough room, times e to the negative 2x times negative 2. Right? And again, that negative 2 came from chain rule. All right, where did you go from here? So hopefully everyone can get those derivatives pretty easily, right? Let's center this. Where do we go from here? Use the rule again. Okay, Maya, why can you use L'Hopital's rule a second time? Make sure we are very explicit with this. Right, substitute 0 again, and you actually do get 0 over 0 a second time. So let's see. So, right, if I do direct substitution, gives, right, up top I get 0, right, from the 6x. And down below, this first term gives me 0, right, 1 minus 1. And the second term again gives me 0, right, because of that x. So I do get 0 over 0. So use LR again. Okay, so we use LR again. Okay, so now up top, the symbolic function, I'm gonna have to use product rule, right? I have to use product rule. So derivative first times second, so I get f double prime 3x squared times 6x by chain rule, and then times the other 6x that was already there, plus f prime of 3x squared times 6, right? So that's just product rule. With chain rule, right? When you differentiate the f prime of 3x squared, you need chain rule. Now down below, the denominator should be a very straightforward derivative, right? It's not symbolic or anything. So the derivative of e to the negative 2x minus 1, so that's just e to the negative 2x times negative 2 by chain rule, right? The minus 1 goes away, it's a constant. And then for the second term, first of all, the negative 2 is a coefficient, so let me keep that on the whole thing. And I'm differentiating x e to the negative 2x. So that gives me 1 e to the negative 2x plus x e to the negative 2x times negative 2, again by another chain rule. Okay. All right, so it looks ugly, but derivatives should be very automatic for you guys now, right? Hopefully. I mean, maybe you have to think a little bit about the symbolic function because that's sometimes a little tricky. But the other stuff using product rule, that should be pretty straightforward. Should be second nature by now. Hopefully. Okay, so I did L'Hopital's rule twice. What now? Do I use L'Hopital's rule a third time? Nishika, you're shaking your head. Substitute 0. So Nishika, you said do not use L'Hopital's rule a third time. What happens instead?
The numerator would be a constant.
Yeah, let's see what happens with the numerator. The first term is obviously 0, but the second term is not, because that I get 6f prime of 0, which is not 0, right? Because we're told that f prime of 0 is equal to 5. Okay, so we're definitely not going to get 0 over 0 anymore. So we should be able to just substitute. So up top we get, so 0 plus f prime of 0 times 6. And down below we get e to the negative 2x, that's 1 times negative 2 plus negative 2 times 1 plus 0. Okay. So that is definitely not 0 over 0. Altogether, if we put in everything, what do we get? We get 6. We get 5 times 6 over negative 4. So we get negative 15 over 2 is our final answer. F double prime of 0 is not 0, but the 6x is 0. 36x squared is 0 if you substitute x 0. X equals 0. So that's it. Why do you need that f double prime as continuous? Like, why did I actually put that in the instructions? For a few reasons. For instance, first of all, if f double prime is continuous, that means f double prime, first of all, exists. So that means f prime exists and f exists, and they're all continuous, right? So in other words, when you, at the very first step, when you substitute x equals 0, you're actually allowed to do that, because if f is continuous, the limit as x approaches 0 is the same thing as just substituting x equals 0, right? So that assumption is there just for you, so that it's valid for you to be able to just substitute x equals 0 at any step. If you didn't have that assumption, then you wouldn't necessarily be able to substitute x equals 0. So it's kind of just a technicality. It's not really too important for the problem. Okay, so that's